Hello guys, so today I'll be showing you ARIMA Time Series model. So today's agenda will be what is ARIMA model, then I'll be showing you tab R connection, then we'll move towards a demo showing the ARIMA Time Series model. So what is ARIMA model? Basically ARIMA model stands for Auto-Regressive Integrated Moving Average. So the difference between linear regression and ARIMA model would be ARIMA model is regressed on their own lagged value, while linear model in linear model the dependent variables is regressed on a number of independent variables and not on its own lagged value. ARIMA model has an advantage as it tackles the problems like trend and seasonality. As we can see in the second chart that there is a trend moving upwards. So these problems are tackled by ARIMA model and not the linear model. That's the reason ARIMA model is preferred over linear regression. So, what are the steps to generate a ARIMA model? First, we would like to visualize the time series. Then, when we visualize, we see certain problems. Like in the previous chart, we can see that in the second chart, we can see that the time series is not stationary. So to stationarize the time series, we could do various things like differentiate the time series in first order, second order, till the time basically the series is stationarized. And there are various tests to understand if the series is stationarized or not, like ADF or augmented Dickey-Fuller test. Then we would like to plot the ACF and the PCF charts to find the optimal parameters used for modeling. For instance, the ARIMA model could be AR model only or MA model only. For instance, it could be AR1, MA1, which are then integrated. And if the series are not stationarized, then the series are differentiated first order, second order. That will tell you the I quotient. For example, if the entire series is differentiated once, and from the ACF and the PACF charts I understand that the model is AR1, then the entire model becomes 110. Then on those optimal parameters we go ahead and build the ARIMA model and make predictions. So after this I'll be showing you how to integrate R with Tableau. So there are these first three commands which will be using to start our R studio. So I've already used all these three commands: install.packages, library rserve, install.packages forecast. So after this we'll move to Tableau, and as usual we'll go in help and settings and performance, manage external service connections. The port will be 6311. I would test the connection, successfully connected to rsir, and then OK again. So first I'll be showing you the data set. So here begins my demo. So in the demo, I'll be first walking you through the data set. Here the data set is about a bike servicing center, as in on everyday basis, how many number of bikes have arrived for servicing. For instance, on 825, there are 8 number of bikes which arrive. Then there are on the similar basis, these are the counts. Then we move to the ARIMA time series modeling. Here first I'll be taking my date time, and moving it to month. Then I'll be taking my count. I can see that there is an increasing trend. So my linear model won't be the best approach, as there is a upward trend in the entire time series data. So I would like to use my ARIMA model. For that instance, I've created a forecast calculated field. So here exactly is my calculated field. So inside the script real, I have written the query required for forecasting. So here is my argument 1. So argument 1 is nothing but the count, the which are occurring on everyday basis. Apart from that, this is my 12. So 12 could be anything, 10, 9, 8. So 12 here talks about how many months in future you want to predict. For instance, I want to forecast for 12 months. So, and my data set, I have seen my data set, studied my data set, and understood that it starts from 2012. So, my starting year would be 2012, and it's on the basis of monthly, frequency is 12. Then, all that I've passed to my time coefficient. I have used the most vanilla sort of ARIMA model, that's auto ARIMA model. So, and then I've used the forecast library, which I have shown in the commands how to install in R. Um, and then I've appended the entire query to show my forecast, uh, including the previous months. So this is my calculated fee. Then I would like to display my forecast. Okay. After that, I have created another calculated field which talks about the color. Here I've primarily used two functions, index and size. Index talks about how many IDs or how many indexes are present in the dataset. Size talks about how many indexes are present in the in that particular partition in that particular year, for instance. So if the difference is less than the index, I have to tell that that's the actual thing. And as I've told that I have to forecast it for next 12 months, coming 12 months, so my number is 12. You can create a parameter also and keep it user friendly, telling that it could be 4, 5, 6, or anything, and just put the parameter instead of 12. So color, I would like to put it in color out here. So I can tell that that's my actual data set till 2030. And after that is the forecast which we have received by using ARIMA model. So that's all for today. Please like and subscribe to my channel. Thanks again for watching. I hope the video was helpful. Thank you.